So I probably should have just added this on to the previous video, but I had stopped and now it's on its own. But just a few more slides, and looking at how the sedimentary structures, or how the sediment formed, can give a little more insight into how it got there. Of course, as we talked about, the sediment forms beds. These beds all together form strata. So if they're all layered, they're called stratified beds. Usually these beds are actually quite large, so spanning across maybe even a whole state. California is a little unique in that it's got so much tectonic activity, or had in the past, that it's all jumbled up here. But if you go out into the Midwest, you'll notice that it's very, very flat, and that's because there's very, very flat plates there, and there's not much going on in the way of tectonics to mess that up. There used to be a big ocean out there that was filled in and made those very flat beds, and now they're slowly eroding away, but that's how you get all those, a lot of that really interesting geologic sandstone features out there. As we talked about, the beds are made flat. If there's higher energy systems like a big flood or a storm, you'll get more larger grains in whatever your sediment is. Otherwise, you'll get much smaller grains, usually if it's a slower or lower energy state. And bedding may also sometimes reflect some non-deposition or erosion. So you had a bed there, it was a very thick bed, and then a whole bunch of it got ground away, or sort of taken out down to a certain level. Even though it used to be very big, now it's thinner. But that can still often happen still in a bed. In these beds, they can preserve a lot of different features. We'll look at a number in different types of sandstone, or I think it's just a couple. But one, of course, that you probably have seen if you've been to a lake is that lakes oftentimes have these little ripples underwater. These, of course, if the rock is lithified before it gets a chance to be disturbed again, or if a whole bunch of dirt is slowly layered on top and it doesn't disturb that feature either, and then it is lithified again, it will preserve those ripples. Another really interesting one is the bedding in sandstones caused by winds. And so some of you may have seen sand dunes out on the beach or sand dunes out in the desert. As those sand dunes form, the sand sort of gets blown up on a little mountain, and then it slides down the hill, and it gets blown up on a little mountain again, and slides down the hill. And as this happens over time, it gives this look at their sort of fishbone feature is sometimes what it's called. But it's a long line between two different layers, and then a whole bunch of little tiny ones going in between. And you can actually go out and see these in some places. This is a great example here, and we see that same little feature, and then it asks the question, which way was the wind blowing in this area? And going back, just looking at this, see how they're all sort of slanting upwards towards the way that the wind is blowing? So looking at this picture now, we see they're slanting upwards, and we can take a pretty good guess that the wind must have been blowing from the left side to the right side. Sometimes the features that are preserved are from deep underwater. These are turbidites, is the term for them, and it happens when there's an underwater avalanche. And so a whole bunch of sand from usually the edge of the continental shelf suddenly tumbles down that continental shelf. As it's tumbling down, they're usually very big, and it stirs up all this sediment with water. And just as you might have seen in a playground or something like that, the little pebbles that are heavier settle out first, and then the sandier stuff settles out, and then finally at the very end, the silt settles out on top. And so if there's an area that's only being added to by underwater avalanches, there will be this consistent feature. It'll be these rough rocks on the bottom, and then it goes to fine stuff. And it might have a lot of fine stuff or little stuff, but then all of a sudden another avalanche happens, and it adds that rough stuff in again. This is what we call graded bedding, and it's graded out by all the stuff being mixed up together and then having time to settle out. Last one for this lecture is mud cracks and sort of mud in general. Mud forms in a lot of different places. This mud is made up of really fine silts or clay, and if it dries out, it has this cracked feature, and then if you have something that comes through and covers up these cracks with some sand or dirt before it erodes them away, they'll actually be preserved there. You can even see in some places out in the desert there's raindrops in sandstones that have been preserved. And of course, since all this stuff has been there for a long time, or might have been there for a long time, some of it spans back to different creatures that might have been running across it, such as this giant dinosaur foot, all sorts of different what we call trace fossils, so worms wiggling across in a mud zone, or an old snail crawling across, or a shell moving across, or creatures like dinosaurs running across it. And there's actually lots of places that you can find these different trace fossils marking their way across the ground. Great, I hope everybody learned something, and I will be back on Wednesday for the morning class, next Wednesday for the morning class, and then next, I'll see the other night class next Monday night. So not this Monday night, but the next one. Adios.